My dear friends, welcome to HIERARCHICAL classes on applied data science with Python. This is lecture number 488. In this lecture, we will try to understand space and time complexity of hierarchical clustering algorithm. The space and time complexity for hierarchical clustering, let's look at space complexity. So it is roughly order of n square, where n is the number of data points, because you need to store your similarity matrix, isn't it? What we have to store? You have to store similarity matrix or your distance matrix. Space required is order of n square, which is actually lot when n is large. When n is large, n square is very big, isn't it? N square is very big number. Now let's look at time complexity. Time complexity is roughly order of n cube. We can have at most n iterations. We can have at most n iterations or steps, because in each iteration we are grouping two clusters. There can be at most n groupings, isn't it? Yes, because at the end of all iterations, we have one large cluster which contains all the points. So you can have at most n iterations. In each iteration, you need to update your similarity matrix. Updating similarity matrix and restoring it, all of that is roughly about order of n square, isn't it? What is it? It is order of n square. So the total time complexity, is order of n square, n into n square, that is order of n cube roughly. Order of n square and order of n cube are large complexities, because n can be a large number. Imagine if my n is let me say 1 million, that is 10 power 6. Order of n square means 10 power 6 into 10 power 6, that is 10 power 12, that is 100,000 GB gigabytes, that is which is equal to 1 TB. I need 1 TB RAM. One of the biggest problem with 1 TB RAM, this is very expensive, and this has to be stored in RAM and not in hard disk. One of the biggest problem with agglomerative clustering is it is not very useful when n is large. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.